Hi, this is Kevin Trainer, and welcome to my tutorial demo. This demo is associated with Chapter 7 in the Reggies and Step Java book. And Chapter 7 is about arrays. So this particular demo example is going to be called PercentAboveAverage. And here's what we're going to do. We're going to get in an array of integers, and we're not going to know a lot about it other than that we're being passed an array of ints, okay, and that we would like to calculate the percent of those int observations that are above average. Okay? And why did we pick this? Well, we picked it because it's a kind of problem where you have to read the data twice. Okay? Because you have to read it once to figure out the average, and you have to read it another time to figure out how many of the observations were above average. This lends itself to arrays or any other kind of data structure that would allow you to process the data more than once at your leisure. Okay? So that's why we're doing it. It's a typical use case for arrays. All right. So we're working here in a project I have called Chapter 6 and 7 Demo. And I've created two packages. One for the work I'm doing in Chapter 6. One for the work I'm doing related to Chapter 7. And the package for this Chapter 7 demo part is called net.ligent.students.chapter07. So I want to create a new class. And I've said that this is going to be called PercentAboveAverage. Okay? And this is going to be the kind of class that kind of tests its own methods, kind of old style testing by inspection. Okay? So the first thing that we want to do is we want to, create some test data and then try to get some answers back. Okay, so in order to get some test data, we need an array of ints. Okay, so how do we declare that? We say int bracket bracket. Okay, that's how you declare an array of ints. And let's call this test case 1. Okay, equals, and we're going to use the option that I hope you remember from the textbook, where we put into curly braces the values that we want to initialize the elements of the array to. So this is called an array initializer. Okay, so let's have 3 values, 55, 11, 12. Okay, close it up and do that. All right, so that's a shorthand way of allocating, of declaring a new variable, test case 1, that can hold a reference to an array of ints, and then creating a new array of ints with 3 ints in it. Okay? All right. Now, let's see what we can do. So let's, if we want to know the percent above average, we probably want to know the fractional percents as well. Okay, so let's say we want to double percent equals, okay, and then let's say we want to calc percent above average. That's the worker method. Okay, and what are we going to pass? Well, we're going to pass test case 1. That's our simple test case. Okay. Now, we've called a method that we don't have, but that's not so bad. Let's just take the quick fix where we ask it to create the method skeleton for us. There it is. It made it private. That's usually a good thing. This isn't a method that we're going to want to share right now. Okay. So we've got that. And let's just take a look at this. Calc percent above average. Okay. Let's take a look at that. Okay. So let's do a little test-driven development. Okay. So it says right here it's going to return 0. Is that what we're expecting? No. Let's see what we are expecting. It's sys out. Okay. Percent. Okay. Well, that looks good. Okay, so what are we expecting? Well, we 11 and 12 are on the bottom, so the average is going to be higher than both of those because it's going to be in about the middle. So I'm going to say that 55 is going to be the only one above average, and we're going to expect 33.33%. Expect 33.33%. Okay? All right. See that. Let's run a test. Ooh, 0.0. Okay. Well, that wasn't what we were expecting, but we were faking it. All right. So we're expecting it to be 1/3. Okay, so let's return, let's cast as double 1 divided by 3. Okay, so that should give us 33.33%, I'm thinking. Okay, so we're gonna try to force a pass. That's interesting. So that's not exactly what we want. We want that times 100. Okay, times 100. Is that going to get us what we want? Well, kind of going to get us what we want, but isn't that too many decimal places? Okay. So let's do a little bit of work. What I want to do is I want to create a method that is going to print out our answers because we're going to have more than one test case. And in that method, I'm going to put the extra code that we need to format exactly the answer that we want. Well, I'd like 2 decimal places. Okay, so you may remember that we can highlight any block of code and we can right click and we can say refactor extract method. And let's call this print answers. Print answer line. How's that sound? Something like that. Okay, so we've got a private print answer line. Now, is it always going to be 33 1/3%? No, probably not. Okay, so maybe we want this one to say up here, expect 33.33% when we call print answer line. Okay, All right. So let's just see. We shouldn't have changed anything. This is a typical refactoring where we've just refactored the code, but it should be doing the same thing. Yep, still doing the same thing. Now, there's a method in our textbook for how to print just as many digits of the fraction that you want, and this is using the printing formatting pictures. And I want to show you another one. Okay, so within our print answer line, I want to declare something that is going to help us print out the number of decimal places that we want. There's a class called decimal format. Decimal format. Okay? And it creates little decimal formatting tools that are ready to format a double to a particular number of decimal places. So we're going to call this one 2 digits. Okay, this is a little tool that will format any double to 2 decimal digits. Okay, equals new decimal format. And what do we pass in? We pass in a picture string. Okay. And how could we find out how to properly populate the picture string for it? We could go to the Java doc and look at the write-up on the class as a whole, and it's got very good examples of how to pick the picture strings. But I just happen to know if we want a whole number plus 2 decimal places, that we give it a picture string of 0.00, and that works. Well, we still can't see the class. It says it wants to import decimal format from java.text. Oh, that's it. It's in java.text. So that's there. All right. Now, how do we use it? Well, we use it as a tool. So we use this object and we call the method format, and then we pass it a double. So we can say 2 digits dot format, call it with percent, and we're going to get a pretty little formatted percent. So let's do that. Let's save it. Let's run that test again. 33.33. Okay, is that what we want? Well, we don't want it to say exactly like that. We probably want to say 30.33, and let's add a little bit more text. 33.33% of integers provided were above the average. How's that? That looks good. So let's save that, run another test. That looks beautiful. Okay. Now, I'm going to point out that we're doing a bit of test-driven development here because we may not be testing with JUnit because we're testing things that have not been kind of batched up into object-oriented classes, but we can use those same test-driven development principles even if we're using conventional testing by inspection, and it worked pretty well there because so far we don't really have the working code into calc percent above average, and yet we've been able to use the method as though we have, and we can see that if we can write the method to give us a good answer, then that's going to be just fine. Okay, so let's create a more sophisticated version of count percent above average. Okay? So what I want to do is I want to assume that we have a normal case. Okay, so what do you need to know the percent above average? Okay, well, you're going to need at least two. You're going to need at least two observations. Well, that's not true. Yeah. Nope. Yeah, to do a normal case, you're going to want two things, you're going to want to average them, and then you're going to want to come from there. If you've only got one thing, you've got a special case. Right? And I see that we've misspelled, no, I thought we misspelled average, but we haven't. Okay, good. So let's assume that we've got three or more. Okay? So I don't want to use, for this array, I don't want to call it the same thing I called it up here. I want to emphasize that it's this is a parameter here, and we can give it its own name. So let's call it observations. That's what the data scientists might call it. Okay. So we've got that. Okay. So I think what we want to do is, first of all, we want to figure out what the average is. Okay? Now, we could, if we wanted to, we could keep passing this down to levels of method. We could create a method that would calc the average. Okay? But let's try to put it all more or less in line right here. Okay? So let's try to come up with the average. So to come up with the average, we need the sum and we need the count. Okay, so how can we figure this out? So let's do this. Let's say we want to create an int called sum and give it an initial value of 0. We want to create an int called count and give it an initial value of 0. And then we want to go over the array. Okay, we want to go over all the observations in the array, and we want to sum them up and count them. Okay, so let's do that. I'm not going to worry about there being too few of them right now. Okay. Okay. So I'm going to show you a trick here. We can just say for, because I'm going to ask for a for loop now, and then I'm going to do control space, and it says, oh, do you mean you want to iterate over an array? Yeah, I do. Double click on that, and it creates a proper for loop to visit all of the items in the observations array, because it says it's going to go from 0 to observations dot length, or it has to be less than observation dot length. So length is a field, typically with objects like arrays. In a couple of minutes we'll get to the fact that arrays are objects, even though they're kind of in sheep's clothing. We are here referring to a field of an object. It turns out this is a read-only field. Okay? It is a constant. Now you might say, well, if it's a constant, shouldn't be all caps length. And I'm just going to say, yeah, if they'd followed their own rules, they would have done that, but they didn't. Okay? So length is not a method, it's a field, and we're able to read it directly because it's a constant and we are not able to muck with it. Okay? So if we want to go to each of these, then let's see. Every time we get to one, we want to up the count by one. Oh, sorry. Let's back that off. We want to say count plus plus. Sorry, count plus plus. Okay. And then we want to say sum plus equals. We want to add to sum observations index I. Okay, so now we're going to go through all of them right there. Okay, that looks pretty good. All right, so if we've gone around, then we ought to have the count and the sum. Then we ought to be able to calculate the average. So the average is, we're going to want it to be a double. Okay, so let's say double average equals, and we want to take the sum divided by the count. But it won't take a whole lot of thinking there. If you think back to when we were doing our math, if sum and count are ints, okay, we're going to get an integer division. We're going to throw away the fraction. Whoa, that's not what we wanted at all. So you may remember back we had a rule that said if you want to get a double result, you can use a cast. So we put that expression in front of the calculation and say we want a double. We want you to use double arithmetic in order to calculate that. And that's going to give us a proper double average. Okay. Alrighty. So we got half the problem done, right? Okay, let's do that. Now we have to process the array a second time. Okay, let's just do this. So before we process the array a second time, what do we have to count or measure something the second time through the array? Yeah, we do. We need to count the number of observations that are above the average. So why don't we create a variable for that and initialize it? So we'd say int count above average and give it an initial value of 0. Okay, that's good. So let's do another for. So let's say for, control space, iterate over array, same deal. Okay, so we're going to go over the array. And what do we want to say? Well, we want to say if the observation is greater than the average, then we want to bump up the count. So if observation, and which index do we want? Well, I, the one we're looking at right now, if it's greater than the average, then we want to take count above average and bump it up by 1. Okay. I'm sorry, it's observations sub I, not observation I. Okay, so when we finish with that loop, we should have a count. Okay, so now we need to calculate the answer. So let's say, well, let's just do this. Let's declare a double answer equals 0. Let's just put that up there just for the heck of it. So down here, let's say that we can just say answer equals, now that's a double, Now, let's say we could say count above average, that's an int, divided by the count. Okay. But then the problem is we're going to need that times 100 to turn it into a proper percentage. And then also, we don't want this expression here to go bad. So let's cast it all as a double. Okay? And that's probably going to take just what we need. And then let's, in the very end, let's return answer. That looks pretty good. Okay. So let's see if that makes sense. Okay. So, okay, we got this in. We calculated the average. We didn't worry about having too few observations. We'll worry about that when we improve it. Okay. Having the average, then we calculated the count above the average, and then we turned that into a percent because we've got count above average divided by count times 100, and we want it to be a double. Okay, so now when we run this test case, we're really expecting to get a real 33.33%. Let's save it and run the test case. 0%. That's not looking good. That is not looking good. Well, that's the nature of this kind of work. We've been testing and we've got to find our error. So it seems to me that I probably have gone awry in this calculation of the answer. Okay, and let's see what I might have done wrong. Well, it looks like I have used this cast of the double here to get what I want. But because I've grouped these first two, okay, and not the third, even though I could group all three because of the commutative rule, then I think I have, because this is an integer 100, I'm losing my fractional part. Okay, so first of all, let's try it without any parens at all. I know I always complain about no parens, but let's just look. Okay, so it's taking that whole expression and doing it as a double. So let's look, let's run it. 33.33%. Okay, so I think I'm okay with this. I mean, you can mix multiplication and division. You don't have to worry about the order in which they're done. So they're done from left to right, and that's going to give us the right answer. And we want to cast that whole expression as a double. So I think I've fixed that problem. Okay, now let's see if we can put some other test cases in. Okay, so now we've got 3. Okay, let's see what happens if we have a test case with 2. No, let's just say 4. Okay, so let's just do 4th values. Okay, so we've got test case 2. And let's say double percent. So we don't have to declare that anymore because it's already declared up ahead. And let's say test case 2. And let's say that it's got test case 2. Let's say it's still going to have, let's say it's going to have 2 above average. So let's give it another one on the top scale. So say 54. So 2 above the average, 2 below. Okay, and then we're going to expect half. So let's say expecting 50.00%. Well, let's look at that. See if we get it. Yeah, 50%, and that one worked fine. What if we only had 2 values? I think this code should work okay if there are only 2 values. Okay. Okay, so we've got 2 values. Okay. By definition, with 2 values, okay, we're only going to have one that's above the average. One of 2. So that's going to come out at 50%. Now, I want to point out that you can't just say, oh, let's reuse the variable test case 2, because these array initializers can only be used when you are declaring and initializing the variable. I know that's a pain in the butt, but that's true. So that's why we're going to make it test case 3. And then we're going to make this test case 3. Okay, so we're expecting test case 3 to come back at 50%. And let's see that. Okay, that's good. Now, do we expect it to work if there's only one? Well, I think it's going to give us a weird answer, but it's okay. If there's only one, right? Now, so the average is just that value. Is anything above average? No, we should expect 0%. So if we wrote the code in a sufficiently robust way, okay. So let's send it just 55. Okay, so we're doing that. This is going to be test case 4. Test case 4. I'm predicting we're going to get 0.00%. And let's see what we get. Save it, run it, 0.00. Okay. What if we don't, is it possible to have an empty array? Well, I'm going to go out on a limb here and tell you that it is. So if we had an empty array, okay, would we run into trouble? I think we will. I think we're going to divide by 0. Let's just go look at this one. So let's copy this one. Okay. Let's just put a bunch of spaces in here. Okay. Make this test case 5. Test case 5. Now, I think it would be nice to give back a 0 here. I mean, as an alternative to blowing up. Okay, so I would like to get the answer 0.00, but we're going to blow up on division by 0. So let's look and see if that happens. Run. Oh, so we're getting a questionable value. Okay, so we did a division by 0, but the answer became not a number. So that's not what we want. We didn't blow up, but that's not a proper answer. So how can we get that to say 0? Well, let's do the following thing. Let's check when we come in. Okay. And if, so let's surround this with an if. Let's check to see if we got 0 observations. Okay, so let's surround with if statement. Okay, so if observations dot length equal 0, okay, oh, let's just say if it's not equal 0, we're going to do that. Okay. Doesn't think we're going to add a return. Oh, sorry, we have to put the return down here, because we have to return no matter what. Okay, so we calculated that one the right way, but we weren't returning it the right way. Okay, so we assumed that the answer is 0. That's the answer we want. If we get it, if the length, if we don't have any observations, then we're not going to change that answer. We're going to be returning the 0. We're going to get a 0 answer now. So whereas right now we get this goofy figure, we're going to get a 0 here. Well, that's not good. That's not good at all. Oh. If the length, I'm sorry, we're going to say if it's greater than 0. We're going to calculate it. If it's 0, we're not. Let's try it again. Yeah, so now we've forced it. Okay, now I'm gonna give you one more test case, and you're gonna go, Kevin, this can't be true, and I'm gonna say it is. It's horrible. Arrays are objects in sheep's clothing. So it's possible for us to initialize this to the value null. And you say, oh, say it isn't true, Kevin. That's horrible, because when we go to work on this, for instance, when we go to ask the length of it, it's probably going to blow up because we don't have a real object there. You gave us a null. We're not pointing at a proper array. Well, don't cry about it. I have a fix. Okay? All right, so let's save this. Now, what I would like to send back, if they send us a null object, I just want to send back a 0 answer. Okay? Yes, I could blow it up. And we've seen exceptions here, and it's possible to throw our own exceptions. So we could throw an illegal value exception, but we're not really at that point yet. So let's see what happens now. Well, we should blow up. Let's run a test. Boom! Java.lang.nullPointerException. Let's double click on that. Where does it happen? Oh, sorry. I don't want to send a breakpoint. Let's just click on that. Used to be if you clicked on this. Let's see where we are. PercentAboveAverage, Java 43. So I think we're here. Yep, right here. That's where we were. Well, that doesn't work because we don't have a proper observations object. Okay, so here's what we can do. We can say if, okay, something or double bar for the cutoff, okay, okay, I think we want and. Yes, and, sorry. And so we can say if observations bang equal not equal null and observations.length is greater than 0, then we calculate it. Otherwise, we're just going to use that default answer of 0. Okay, so, well, we need to group those two expressions together. Now, a lot of people wouldn't have the double parentheses here, but I kind of like the way they read. So let's look at this, save it, let's run it. The last one's going to come back as a 0 as well. So we've got what we wanted. So because arrays are objects underneath, even though we're not, you might say, well, we didn't create a new array. Okay, well, think about strings. Strings are unusual objects with their own syntax as well. Okay, that what's true for array is true for string. They have their own syntax. Okay, so there are special rules that apply to them, but they are objects, and it is possible for them to be null. And so if you want to write a really robust method that you pass arrays to, not only should it behave well when it's populated in a conventional way, but it should behave well if it's populated with 0 members in the array, and it should also behave well if it's if you get past a null. So what we did here is we said, okay, our default answer is it has 0% above average, okay, and then if we have a proper array, and if it's greater than 0 long, then we're going to do our work. Okay? So that is that. You should be able to do this kind of work. If you can do this kind of class, then you ought to be able to do I think there are 2 exercises in the assignment. Okay? Let's just go back and look at the different things that we did to review them. Okay? First of all, we did a little razzle dazzle here. Even though we wrote this the conventional old way that we tested, where we're testing by inspection, we actually did test-driven development. Okay, so we actually wrote these tests, which are in main, before we wrote the rest of the code. And then we, I guess we forced a failure, then we forced a pass. When we forced a pass, we could see that we didn't like the format that we were getting for the answers. We were getting these repeating fractional digits. So we came in, we factored out the print line into its own little method, created a decimal format object that will format any decimal. It'll format a lot of different kinds of numbers, but in this case we had a double. And we gave it a picture when we constructed it that we wanted at least 1 digit before the decimal point, and then only 2 digits after the decimal point. And then we used that in our printing, and as a result we got just the string that we wanted. And then of course when we calculated the percent above average, we concentrated on the normal case first, where we had enough observations. Okay, and we got it to give us take care of all the normal test cases. And then we went back and we remembered that it's possible to get past an array with 0 members populated. So we improved the code to behave appropriately with that. And then we dealt with the issue that we could be passed a null object as the parameter, and then we made the code a little more robust and check for that. And I want to check that the reason that this expression works with a null is that we use the amper, which is a cutoff version. So it says if the left expression is going to fail, then it's not going to check the right expression. So it's the right expression that blew it up when it was a null. But because we check the left one first, we go, oh, it is null, it never runs the test on the right. And as a result of that, we don't blow up. So that's it. Good luck on your exercises, and I'm going to say bye until next time. Bye-bye.